Up there. SOS. Alright, most common and best function property that we use, it's the one Tyler just rhymed with, or distribute, or whatever it said, the distributive property. Okay? Distributive property, just going to give you some letter examples of all these. The distributive property tells us that if we have something right outside the parentheses, all we're going to do is distribute it to everything inside the parentheses using multiplication. Take whatever sign's in between them. You could also go, I always said last year in Algebra 2, you could go backwards distributive property. So that would also be the same as if we were to factor. So I could take the AB plus AC and say, well, I could undistribute that by taking an A away from both of them. And you're back to where you started. So it's a circle we could run in. Okay? But remember the strip property. We're going to work examples in a second. We're just going to look at the properties. The next property on the list today is the inverse. Our inverse property. Inverse always means opposite to me, so I'm thinking about that. If I'm dealing with addition, the inverse is what I can add to it to get 0. So you're adding the opposite. But if we put it in multiplication context, it's going to be the reciprocal. So it'll be what we multiply it by to get what? What do you get when you multiply reciprocals? It's not 0. Now remember? 1. Good, Rachel. 1. Anytime you multiply something by its reciprocal, the answer is always 1. And reciprocals kind of reminds me of opposite because you flip it. It's upside down. What was on bottom is on top. What was on top is on bottom. Okay? Identity properties. Flying through these to start y'all. Identity property, it didn't change. It kept its identity. So if you're dealing with addition, that would mean you added 0 to it. It didn't change. It kept its identity. If you're dealing with multiplication, what could you multiply by that wouldn't change its identity? Attaboy, Chase. So we'd be multiplying by 1. I was afraid when you moved from the front to the back you wouldn't know as many answers, but you still did. Good job. You just know everything wherever you are. Alright, so next after identity, or the next most common other than distributive, it's our commutative and associative. What you got, Baylor?
I was just going to ask you, like, where it says A plus 0, like, what's after the equal sign up there?
A.
Okay.
Yeah, it kind of looks like a funny G, doesn't it? Alright, so commutative, oops, sorry Rachel, she jumped. Commutative lets you, so U-T-A-T-I-V, lets you change the order of something, and that can work in addition, A plus B, we know it's the same as B plus A, and multiplication. A times B is the same as B times A. Commutative does not work in division or subtraction. It's got to be add and multiplies on. Commutative lets you change the order. And then associative, I don't know why they always group them together, I guess because of the change. Associative lets you move the parentheses. So if I had something that said A plus B plus C, I could scoot the parentheses over and do A plus B plus C. That'd be the same. It works, associative works with multiplication also, so it could be A times B times C and still be AB times C. You bet your boots. Is that good or more? Okay. Okay. Got one more after we get caught up. Just one more. Going to have a great first week of your senior and one junior year. You got a ticket? Speed? How fast? Good Lord! What's the matter with you? Chase?
I was going to be late to school.
Leave earlier.
I have to leave the auto pick in Alexander and be back here.
Wait, do you have to get like a driving school thing?
I had to told me to call some number.
You had to pay your ticket and you got driving school.
If I was you, I'd do driving school.
So it'll lower your insurance.
But don't miss your class because I have
under 18. the judge will keep it off my driver right here.
I was driving to school and I ride to my car the day after.
But you was on 28. I was 27. That's because it's on 9.
If I get a ticket for going 15 over, I lose my license.
Yeah, I'm on driving probation
well?
right now.
Yeah, because I have a
So am I.
CDL. And if you have a CDL,
I got
the laws
6
are
or 4.
stricter.
What's the CDL?
So you can drive a bus. Mine's for a bus, but if I go 15 over and get a ticket, I'll lose
In
my
any
license.
car?
In
My
any
dad-
car.
My dad got to the
Uh-huh.
point to where he had to do it otherwise, okay.
That's no point.
Yeah, my dad has that in his book.
They probably don't appreciate you telling everybody that. Just say.
How many months left in the budget?
Okay, last one that we've got. You, you were doing that?
No,
Oh,
that's what it was.
That's what you were.
Doing what?
75 minutes.
I was on
Like
spring
30?
break, I think, the girl who, I think the student on it,
Maybe
and
40.
When they went to academy.
Yeah.
He drove up with me.
Alright, let's finish these properties and do some problems. The multiplication property of 0. Property of 0. Alright, is what it says, because the multiplication property of 0, if we multiply something by 0, we always get 0. Now, different books and different teachers will call that different things. Right there, I wrote multiplication property of 0. It is also sometimes called multiplicative property of 0. Multiplicative, I like that word. That sounds funny to say. Multiplicative property of 0. So that just means what you learned when you started multiplying in the 3rd grade. When you multiply by 0, you get 0. The multiplicative property or the multiplication property. Now, the intent of this lesson is we're fixing to simplify a lot of problems, and they want us to do it using these properties. That, in my opinion, is not always the best way to do it. And I'll show you an example of why. Lots of times we can just look at expressions and simplify them without having to use the commutative property to reorder them, right? You following? So I'll show you an example of what they want us to do, but we may or may not do that every time. We may just go ahead and simplify because we're good at that. All right, we've got your properties on there, ready to go to the... You got it, Taylor.
So I used to spell multiplication.
I hope so, but I'm not promising. You know me, I don't spell well.
Yeah.
Okay, they concurred. The checker concurred on the spelling. He can check everything. We have a designated checker, and it's Dustin. So if you're ever in question if
I'm
your
sure he
answer's
was sorry
right,
about that.
you check with Dustin.
Or check with Chase. Which one?
He just didn't get the title. Dustin got the title.
He got named.
All right, let's do this. Start off with the distributive property. I got -4 times p minus 5. The directions just say simplify. Okay, about as easy as we can get it here. We're going to take what's outside, distribute it to what's inside, so we get -4p. What about -4 times -5? Positive 20, that's it. Okay, now here's a question. This is going to come into play later on at the end of the class period. Can I combine those two terms? No, that is it. Why can I not combine those two terms?
Because of the variable.
Okay, because of the variable. They don't have the same variable. That's called like terms. Remember that? They are not like terms, and here's the key thing I'm telling you you're going to see later in the period. They are not like terms because they do not have the same variable. The 20 doesn't even have a variable. To be like terms, two things got to happen. Got to have the same variable, got to have the same exponents on the variable. Do I need to say it again? To be like terms, we got to have the same variable, and we got to have the same exponent on the variable. Okay?
Isn't that 18?
Yes, it's 18. Yes, ma'am. All right. Hope you remember that in a little while. What about if I had something that said -6m plus 2m? Can you simplify that? Yes, Aaron's
yeah.
correct on this, and Chase concurs. Reason we can simplify this is what we were just talking about. They are like terms. They have the same variable with the same power on the variable. It's both m to the first, right? First period told me -4, they were correct. And then they told me m squared. Good, that is not correct. Remember, when you add and subtract, exponents stay the same. Only time exponents start getting in on the action is when you multiply and divide. Add and subtract, they stay the same. Don't mess with them when you're just adding and subtracting. Okay, how about 2r plus 3s? How do I simplify that?
You can't.
Good, Kelly? I can't, because their variables are not the same. Now, catch on? Very good. So I would just leave that alone. I wouldn't even do anything to it. There's nothing to simplify on that. Alright, so one more distributive one here. I got 5 times 4p minus 2q plus r. The directions just say to simplify. What we do, first off, we did order of operations yesterday, and it said to check in the parentheses, and I've got parentheses. Can I simplify inside that parentheses any? No, there's no like terms, nothing with the same variable. So what can I do to simplify?
Distribute.
A kid, Mason distribute. 5 times 4p. 20p. 5 times negative 2q. Negative 10q. That's an ugly q. And 5 times r. 5r. Or 5 times r. You can still say it that way. And that'd be it. Okay, nothing else you can do on that. Such a pretty pencil, not pen, whatever it is. I like it. Cool. No, not cool.
From Bill's mom.
Yeah, Mason spelled
Hey,
forever.
babe, you're not.
So what do you provide?
Yeah, it's not that easy, right?
Can you simplify that?
Yes.
Okay, we covered this stuff Wednesday when we did the negative rules and all that. So this would be, they're like terms, right? X and X. So this would just be like one of them minus 3 of them. What do you get? Good job. So we just added an X onto what we did earlier on that. Okay. I gave, this one kind of made first period hit the brakes a bit. I had negative, and then in parentheses I had 3 plus 4p. What do y'all think? What we should do? Okay, good. Baylor and Chase are right on that. A negative out front, you're just distributing it, and it's like distributing a negative 1. So that'd be negative 3 minus 4p. Okay. Now here's what I was talking about, the problem I'm fixing to show you. I'm going to do it first the way that it's intended to be taught, using the properties, but then I'm going to show you how I did it with you in Algebra 2 and how I will continue. And you can pick your favorite. Doesn't matter to me. Everybody got what you need on that one? Let's see a couple of you. Finish up. Alright, it says negative 2m, oh, hit next page, there it goes. Negative 2m plus 5m plus 3 minus 6m plus 8. Alright.
Is that 6N or 6?
M, it's ugly, it's an M like monkey. That's important though, we need to know that. Those are all M's like monkeys. Okay, here's the way that this is intended to be done when you're covering the properties. We've got things on there that are like terms with our M's, and we've got things on there that are like terms with our constants. So we've learned that when we're using addition, we can move stuff around using the commutative property of addition. We can even throw some parentheses using the associative property. So I'm supposed to tell you that you need to keep negative 2m and positive 5m, bring negative 6m over, group your m's together, then group your constants together. Oh, I missed that parentheses. What the heck did I do that for? It's supposed to include the 3 in there. Alright, that's what we're supposed to do, because that would be using the properties that we just did. We reordered using the commutative property to get our like terms by each other, and then we just grouped them. Okay? There's nothing wrong with that. It's completely correct. Negative 2 and 5 is 3. 3 and negative 6 is negative 3. Okay? 3 and 8 is 11, and then we got our plus. What do you think, Dustin? Good? Good. Nothing wrong with that. If I were working that problem on my own, or if I were helping you work it individually, you wouldn't need help, but I would not do that. I would never do that. Doesn't mean that I'm wrong or more right. I just wouldn't do that. What I would do is I would keep the original problem and I would just combine like terms and look for them as I go. So I would, remember I told you we're going like term hunting. We get to get our hunting stuff ready. Negative 2m and 5m is 3. Okay, done with those. I'm at 3m. Here's another one. 3 and negative 6m. That's negative 3m. Done with that. Here's a constant, and there's a constant. Same answer, same thing. It's just, I did actually do this. I moved them around in order. I just did it in my brain without writing them down. So I don't care if you rewrite them or not. To me, it takes more time and you don't really need to. So I'm probably not going to use the properties the rest of the time writing them. Does that make sense? I'm probably just going to simplify. Okay? I guess I technically am using the problems, but I'm just doing it in my brain instead of writing out an extra step. So, okay? All right. All right. So, here I've got 6 minus the quantity of 2x plus 7 minus 3. This one was difficult the first period. Y'all are smarter than them, I
Is
think.
that plus 7?
Yes, 6 minus 2x plus 7 minus 3. All right, what do we think about this thing? Good. Did y'all hear what Kaylee said? I think it's what y'all were saying over there too. That minus sign in front of the parentheses, that means I need to subtract that whole quantity in the parentheses. So that would be like saying 6 minus 2x minus 7 and then minus 3. Wouldn't that, are you there? Okay, good. Now it's just time to combine like terms. So I've got a 6 minus 7. What does that give me? Negative 1, and then negative 1 minus 3. Negative 4. So there's my constant. And then all I've got left. Bet your boots.
Shouldn't the one there, shouldn't it go first?
I think most of the time you will see it that way. So let me go ahead and flip-a-roo that, what Baylor said. Normally that the variable does always come first. And we talk about writing stuff in standard form. And that's one of the things, this thing with the higher degree comes first. This x is an understood x to the first. A constant doesn't have a degree. So a 1 and a no degree, the 1 is higher. So Baylor's right on that. Technically that one should be first.
You don't count off of that much.
I don't, but I want you to know that in case you see it like as a choice, you would know to redo it. But I would be okay if you didn't. But if it's like ACT or test or something, you need to be able to figure out, oh yeah, I can flip these and you're good. Alright, now we talk about like terms and we have been, and then I give you an expression that says 4m times 2n and ask you to simplify that. Can you?
Yeah.
I've heard both. The checker's right on this one. Yes. They're not like terms though. I'm also not adding or subtracting them. Only time they got to be like terms is when you add or subtract. This is multiplication. You can multiply with different terms. So I would say, well, I got 4m's times 2n's. Yeah, you got it, Chase. That's it. You can multiply and divide. They don't have to be like. Only when you add and subtract. I just jumped way down to a new section. I don't know why. That's okay. It works. Alright, one more and then we'll give you something to do on your own. We already did that one. Let's do 12b minus 9 plus 4b minus 7b plus 1. Those are all b's, those things. Now you could rewrite it and put the b's by each other and the constants by each other. You could, and that's not wrong. If you want to do that, go ahead and do that. I'm just going to find b's down the line as I go. I'm going to go hunting for b's. So I've got 12 of them plus 4 of them. How many B's does that give me? 16. You already got the final there, Baylor. And then 16 minus 7 gives me 9. So I got 9B. We good? Okay. Then left, I've got constants, -9, and 1 is -8. Can I combine this, 9B minus 8? Good grace, nope, because one of them's got to be and the other one don't. It's not the same variable. Alright, we'll give you a handful of these to try on your own and test them with somebody sitting near you and see if you got them right. And then we'll talk about them together. First one, I've got -12 times x minus y. Second one, I've got s plus 9s. Okay, then I've got third one, 5 times r minus 3 plus 6r minus 2r plus 4. One more, -4 plus 4 times 4k minus 3 minus 6 times 2k plus 8 plus 7. So there's got 4 of them there. Do those in your notes. That second one, those are both s's. S plus 9s. That kind of looks bad, so make sure you didn't think those were 5s. S plus 9s. So get those 4 done. Check them with somebody around you. Then I'll pick a number or a card or something or call on you and we'll talk about it.
Is that 2 in a good problem, a minus or a negative?
Minus 6r minus 2r. Everybody's still working and I don't hear you checking with your neighbor yet. tell you what you did. You made a boneheaded mistake. Are you the only one to ever make one? No. Is it gonna be the last time? No. I'll just find it, fix it. There you go.
We got the same first one, but it's a different one.
You can, it's okay, you can look at it, but try to, can, no. You're looking at it like, some trick question. I mean, if you really got, I can't wait, then I don't have any accident, wait. So, you're okay?
I don't know exactly how they are. I did it for the outside, if I think that's possible. So instead of 11, I got like
Where are you putting the positives to?
15.
When she distributed.
I meant 15.
Yeah, so that'd be a negative, you're right. See, you just made a bonehead mistake, doesn't mean you're stupid. Should I give you the same back here?
Yeah. Same thing. I've always been able to teach. So it's like
You know, it takes some practice to watch you use this real hard. If you'll get the pen real close, it'll, the mouse will show you, then you know where you are. That's the trick, you know where you are. You know, if I pick a card that's empty, it's y'all. Look, y'all are gonna get hit. If I pick a card that nobody's sitting at that desk, that'll be y'all every time. Checkers like that.
Yeah, yours is actually 7 on the end. Huh?
Sometimes
Let's
that's
see if we
not
can
the
see right now. It's down right.
But it means the positives of it.
Perfect.
I think somebody's in this one, King of Clubs.
I just forgot a number.
Good, did you get figured out?
Yes.
Sit it down there by you in your area, Zane. What's the King of
Oh,
Clubs?
is that me?
That's Keston. All right, Keston, number one. What'd you get on that first one?
Negative 12x plus 12y.
Exactly right. Checker, you think so? Everybody good on that? Just distributed on that? Very good. All right. Queen of Hearts. It'll be around Baylor, okay? Hunter, what do you got?
I got 10S.
10S, because you got one of them, and you add 9 of them, and you get 10 of them. Good job, Hunter. Alright. Ace of Hearts. Is that Kirsten? No? Is it empty there?
I think that's right there.
Okay, Dustin. What do you got on number 3?
9R minus 11.
9R minus 11. Now this one's going to be hard because he's my checker, so I'm going to default to Chase. Chase, good.
Yes.
Chase agrees. Anybody disagree?
I got 11. Or minus 11.
Okay, let's check those R's real quick. There's 15 of them, right, Mason?
Mm-hmm.
15 plus 6.
No, 5.
5, dumb butt. Thank you. Mason, you agreed with me. There's 5.
Oh, no.
5 plus 6 is 11. So you just forgot to subtract 2 off, Mason.
Oh, okay.
Good, so good dusted on that. Alright, the one everybody's worried about. 8 of Hearts. Is that Michael?
Yeah, and then
What about you, Caleb? You got it?
4K minus 57.
4K minus 57. Does that look good, Dustin? I remember that one from first period. That is correct. Michael, go ahead and finish it. Make sure you get, is that what you got, Mason?
I got 4K plus 39.
Alright, let's look at it. Oh, my.
Major 48 positive.
Did you hear what Chase just said, Mason?
Do I now?
48 is positive.
Probably made the 48 positive. Make sure you distribute a negative 6
Oh,
to
I did
that.
make.
Yep.
Dang, you're
Yep.
Okay.
Alright, anybody else need to see anything on it? Alright, I got real quick, we'll take a second, exit question, and I'll post that. Hope you can go and come back and do the exit question if you need to. So let me get that posted. Go ahead and get your Chromebooks back out. Just grab the fancy new hall pass told her made me, and I'll sign you out.
She made you one of them.
Yeah, me with Michael Jordan.
Are you sure you?
Oh, I saw it.
208, period. Exit question.
I got it.
Like you're a magician, like, are you sure?
Alright, there it is. So refresh if you need to. It should show up for you.
use it once if it's somewhere.
Type it twice, lazy bones.
I had that type of.
Do what's good.